All right, today we're going to go ahead and talk about section 3.2, all right, isosceles and equilateral triangles. All right, so let's recall from last section that an isosceles triangle has at least two congruent sides. All right, it's got to have two equal sides. We think two equal sides. All right, the congruent sides are what we call the legs of the triangle. So our legs are the two sides that become congruent. The vertex angle is the angle formed up by the dot when we draw our isosceles triangle. Now, the side that is opposite of the vertex is called the base. All right, so that's like the bottom of our triangle. Now, the base angles are the two angles that form on the bottom. All right, so if we're looking at this, picture, our vertex is the point where the two legs that have tick marks are congruent. So angle 3 is the vertex angle. It's the angle that takes place up by our vertex point. All right, that means that angle 1 and angle 2 are base angles. Now, you'll notice two equal sides in our picture. What's eventually going to happen, and we're going to learn that today, is that it forms two equal angles by our base angles. All right, so let's keep continuing. So here's what we're talking about. If a triangle has two equal sides, then it means it has two equal angles. Angle B, the base angle, has to be equal to angle C. All right, so two equal sides means two equal angles. It's a base angle, so not the vertex angle, the other two angles. Now, the converse of that is if a picture has two equal angles, then we know that the two sides have to be equal. So DE has to be equal to DF. All right, so isosceles triangles has two equal sides, two equal angles. You'll recall from last chapter when we drew our isosceles triangle, we always drew our picture with the vertex up top and labeled that right away so that we knew we could put tick marks on the left and right side. We will continue drawing our isosceles triangle the same way. All right, now the only difference is now when we draw our picture, we're also going to mark curl marks by the two base angles to show that those angles are equal. So if they give us equations on the sides, we'll set them equal. If they give us equations at the angles where they're marked congruently, we'll set them equal. Remember that all the angles in a triangle have to add up to equal 180 degrees. So we can always find a missing one. All right, let's look at some isosceles triangles now. Okay, example 1A wants us to find x. All right, so here's the problem. I know that there's two equal sides, which means I know that A is my vertex. So I'm going to make a little dot on A because I know those are the sides that are equal run into that point, which means that there are two equal angles. So I'm going to put a curl by this angle and by this base angle to illustrate that they are congruent. Now, since they are the same, if this one's x, then this one's x. So technically, I could take 180 or write an equation and say 2x plus 38 equals 180 degrees because three angles add up to 180 inside a triangle. Now, we could solve that by 180 minus 38. All right, if we do that, it gives us 2x equals 142. If I divide by 2, I get 71. All right, so each angle would have been 71, and that would match. Adds up to 180. Now, the other way people could have looked at that is they could have said, well, let's go back to the original picture. I know that those were two x's. I could have technically taken 180 minus 38 to find out what's left, which gives me 142. And then I can divide that by 2 because there's two equal angles, and you'll notice you'll still get 71. So there's multiple ways that we can solve this. All right, let's look at letter B. Now, letter B is more of the converse. You'll notice in the picture they give us two equal angles. Well, if those are the two equal angles, the point away from it means it's the vertex. And the two sides that run into the vertex would get tick marks to become congruent. All right, we're picturing our two angles, equal sides, two equal angles. So in this picture, 2x plus 6 has to equal 8x minus 18. All right, we're going to solve for x, so we'll subtract 8x from both sides. We're left with negative 6x plus 6 equals negative 18. If I subtract 6 over, I have negative 6x equals negative 24. And now when I divide by negative 6, I get x to turn into a positive 4. All right, let's continue on with some more isosceles triangles. Here we're going to draw a picture. All right, so QRS is an isosceles triangle, so I'm going to draw my triangle. I'm going to highlight my vertex and put a tick mark on both sides and curl my angles. Now, in this question, it says with base QR, so I know the base is the bottom, so I'm going to put Q and R on the bottom. And the missing point of my other triangle would be S then, so S goes on top. Now you'll notice this picture gave us two letters, so they're talking sides. So now I'm going to label my picture with the correct sides. So QR is 6x minus 3. QS is 9x minus 1. RS is 8x plus 7. Now remember, the ones with tick marks are equal, so we will set those two equations equal. All right, we will solve our equation, minus 8x on both sides. We're left with 1x minus 1 equals 7, and now if I add 1 over, we are done. We get x to equal 8. Now, this one said find the measures of all sides, so let's go back and plug it in. We'll use Brown to plug it in. If I plug in an 8 here, 6 times 8 is 48 minus 3 tells me this first one is 45. If I plug in an 8 on the left, 9 times 8 is 72 minus 1 is 71. If I plug in an 8 times 8 is 64, 64 plus 7 is 71. Check, I know I did it right. We are on the outside of a triangle, so it doesn't have to add up to anything specific. Only the inside of the triangle adds up to 180. All right, let's keep going. Find the value of y. All right, notice two equal sides, so this would be our vertex where the two sides run into that are equal, which means I'm going to put a curl by the two angles by the base to show that they are equal. Since the equation landed in both of these, I'm going to set them equal to each other. If I solve it, I'll subtract 8y over to get my y's on the left. I'm left with negative 2y equals negative 16. Now I'll divide by negative 2, and I get y to equal 8. All right, here we go. Let's go keep continuing. Find the value of x. Notice these two angles are equal, so 77 and 77 get our curls. That means the two sides right here would have to be congruent because they run into the base angles, which makes angle C the vertex, so the picture's been spun. To find x, I'm going to take 10x plus 31 and set it equal to 15x plus 16. I'm going to solve it, subtract 15x from both sides. I'm left with negative 5x plus 31 equals 16. If I subtract 31 from both sides, I'm left with negative 5x equals negative 15. Now let's divide by negative 5 on both sides, and we get x to equal 3. So again, you'll notice in all these isosceles triangles, we're marking congruent sides and angles before we start the picture. Now let's look at another challenging one. Here's my two congruent sides, so C is my vertex because that's where the two equal sides meet at one point. That means that if those are the two equal sides, these two angles are equal. Well, if those two angles are equal and that one's 42, I can put 42 here. And now this picture has to add up to 180 on the inside because three angles will add up to 180. So x plus 42 plus the other 42 has to add up to 180 degrees. Well, if I combine like terms, that's x plus 84 equals 180. Subtract 84 over, and that'll tell us that the missing angle left is x equals 96. So, quick recap of isosceles triangle. Every time we want to visualize our isosceles triangle, we're picturing the vertex, the two equal sides, the two equal angles. All right, so isosceles, two equal sides, two equal angles. All right, let's get to the last part for today, equilateral triangle. So equilateral triangle, remember, has three equal sides. So here's the deal. If the picture has three equal sides, that means that there's three equal angles. So angle A is equal to angle B is equal to angle C. All right, now think about this. If the triangle adds up to 180, there are three equal angles. So 180 divided by 3 tells me that each one of those angles is 60 degrees. Now, the converse of that is, what if they give us a picture with three equal angles? Well, if they give us a picture with three equal angles, what we can do is we can mark three equal sides. So that means side DE is equal to DF is equal to EF. All right, so equilateral, three equal sides, three equal angles. So here we go. All right, example A has three equal sides, so I know that it has three equal angles. Well, if it has three equal angles, then each angle should equal 60 degrees. So to solve this, we are going to take 3x plus 5 and set it equal to 60, because that's what that angle should be. We're going to solve it by subtracting 5. We get 3x equals 55. And if we take 55 and divide it by 3, we get x equal 18.3. All right, let's look at letter B. Letter B tells us that there are three equal angles in this picture, so right away we know there's three equal sides. If there's three equal sides, then we pick any two and we set them equal. So 2t plus 1 has to equal 4t minus 8. We'll solve it. Let's subtract 4t from both sides. I'm left with negative 2t plus 1 equals negative 8. Let's subtract 1 over. I'm left with negative 2t equals negative 9. If I divide by negative 2, I get t to equal 4.5. Now you'll notice it is possible to get decimals. However, you'll notice we cannot get a negative number for our x or our y, whatever we're solving. All right, let's go to C and D, and then we'll get to a challenging picture, but we won't be concerned too much with the challenging picture today. Letter C gives us three equal angles, so an equiangular triangle. Equiangular means three equal angles. Well, then that means there's three equal sides. So we'll put tick marks on each side. I'm going to pick two sides and set them equal, so if any two, in this case there's only two, 5y minus 6 equals 4y plus 12. All right, let's go ahead and begin to solve that. I'm going to move my 4y over. I'm left with y minus 6 equals a positive 12. I'm going to add 6 over, and I get y to equal 18. All right, well, let's go to letter D. Letter D gives us an equilateral triangle, 3 equal sides, so that means there's 3 equal angles. Well, remember, if all those angles are equal, they all technically equal 60 degrees. So to solve this, we're going to take 2x plus 32 and set it equal to 60 degrees. If I subtract 32 over, I get 2x equals 28. If I divide by 2, I get x to equal 14. All right, so our last one. Stay with us through this one. It is fairly challenging. However, we'll get you through and have you look at it. All right, so here's the deal. We've got to find x and y, and then it wants us to go back and plug it into US. So what I notice in this picture is this triangle right here. It has two equal angles, 50 and 50. If these two angles are equal in an isosceles triangle, then it means these two sides of the triangle have to be equal. So y minus 2 has to be equal to 9. If I add 2 over, that'll tell me that y is 11. All right, so we get our first part to be 11 by focusing on that triangle. Now, a couple things in this picture. If I'm looking at this big triangle, the whole entire big thing, you'll notice that this angle over here adds up to 80 when I combine these two. This one is 80, so these two angles are technically equal on the triangle. All right, what that means is that the sides that run into those equal angles have to be equal. So 3x minus 15 is the whole entire side. Well, the whole entire side of this picture, 9 plus 12, is 21. All right, we're going to solve this by adding 15 over to both sides, and I get 3x equals 36. If I divide by 3, I get x to equal 12 for the problem. All right, and again, that's because of this whole big triangle turns out to be an isosceles triangle. Adds up to 80 in the corner here. This one was 80, so technically the big triangle became isosceles. Now, to find US, we're simply going to plug in our x. So you'll notice US has 0.5 on its line, and it wants us to plug in 12. So US equals 6. All right, we'll look at more problems like that, but the main concern were the problems that we did up above in our examples. From today, there are two main takeaways that you need to make sure every time you label your picture when it says isosceles, that we are now drawing an isosceles triangle. We are putting our vertex up top right away. We are marking two equal sides in an isosceles and two equal angles. All right, anytime it's an isosceles triangle, we want to make sure we mark all of it. If it's an equilateral triangle, or equiangular, then what we want to do is right away we want to mark all three sides equal in an equilateral. And if it's equilateral, it's also equiangular or vice versa, so we'll mark 3 congruent. Remember, if I mark 3 congruent, that each angle is technically 60 degrees in this one. Remember, the inside of a triangle adds to 180. Only the inside. The outside we don't worry about. All right, so those are our main takeaways from today. We're going to get into some practice.